So today, we're diving into some really cool research that asks a totally different kind of question about AI. We're not talking about whether an AI can pass a law exam or write a novel. Nope. We're asking, can it actually learn to reason like a human toddler? We're about to find out what happens when you basically send an AI to preschool.
And it's a huge question, right? Can you give an AI a childhood? What if, instead of just dumping the entire chaotic internet into a model, we raised it on the same kinds of things a child sees and hears? And if we did that, how would we even know if it's genuinely thinking and not just getting scarily good at mimicking us? That leads us right into our first section. Why would you even bother testing a baby AI? Well, the puzzle is that all the tests we have for those giant know-it-all AIs, they're completely useless for these smaller, more specialized models.
Okay, so let's get on the same page. What is a baby language model? It's a special kind of AI. Instead of just swallowing the whole web, all the good, the bad, the weird, it gets fed a super careful diet. Think kids' books, transcripts of parents talking to their kids. The goal isn't to build another search engine. It's to see if we can actually spark a more natural, human-like way of learning. And this slide just lays it all out, doesn't it? On one side, you've got the giant language models we're all familiar with. Their diet is the entire internet. Their goal is to answer pretty much everything, and we test them on stuff like the bar exam. But on the other side, these baby models have a totally different upbringing and a different goal, just learn how to reason. So what goes in that big question mark? What's their final exam?
That really is the core problem, you know? How do you grade an AI that's basically still in digital kindergarten? You can't ask it about legal history or astrophysics. You need a completely different kind of report card. And that brings us to the really clever solution from these researchers, a brand new set of tests called the BabyReasoningBench. Honestly, the best way to think about it is like a developmental checkup for a very young AI. What they did was, they basically built an AI obstacle course. But instead of climbing walls or crawling through tunnels, the obstacles are all mental puzzles. And they didn't just make them up. They borrow them from decades of research on actual human children. They're trying to ground this whole thing in how we really learn to think. This checkup is focused on 4 really key skills. First up, theory of mind. Can the AI get that other beings have their own beliefs that might be different or even wrong? Second, causal learning. Pretty simple. Does it get cause and effect? Third, analogical reasoning. Can it spot patterns and make connections? And finally, core primitives. Does it stumble into the simple logical traps that even little kids learn how to avoid? So, to make this real, let's walk through one of the most famous tests for theory of mind ever. It's called the Sally Ann test. Okay, picture this. Sally has a marble. She puts her marble in a basket and then leaves the room. While she's gone, a sneaky Ann comes in and moves the marble into her box. Now for the million-dollar question. When Sally comes back, where is she going to look for her marble? The right answer, of course, is the basket. And this is the whole point. The test has nothing to do with where the marble actually is. It's about whether you can understand what Sally believes to be true. The AI has to get inside her head, so to speak, and see the world from her mistaken point of view. That is a massive cognitive leap for kids and for AI. All right, so the stage is set. The researchers put these baby AIs through this whole cognitive gauntlet. Now let's look at the report card, because wow, the results were full of surprising successes and some really dramatic failures. So 2 models went head-to-head. You can kind of think of them as siblings. First, you have baby LM10M, the younger one. It was trained on about 10 million words of this kid-friendly text. Then you have its older sibling, baby LM100M, which got a much bigger education, 10 times the data. Now, at first glance, the overall scores are kinda what you'd expect. As you can see, the older sibling with more data did better, jumping from about 28% to almost 41% correct. So sure, more data helps, but those scores are still pretty low, right? And it turns out that simple average is totally hiding the real story.
Yeah, the real story here is that the AI's intelligence isn't some smooth, even landscape. It's incredibly spiky. It can be an absolute genius at one task and then turn around and completely fail at another one that seems almost identical to us. And this is a perfect example of that. Look at this. On tests of simple physical cause and effect, things like knowing a cause has to happen before its effect, the older model gets a perfect score, 100%. That's a huge jump from its younger sibling. It seems to have completely mastered this one concept. But then you get this. When the AI was asked a simple question that has some tricky wording, like asking, are there more dogs or more animals in this picture? Both models scored a 0, an absolute 0. It's a classic linguistic trap, and apparently no amount of extra data helped them figure it out. And this is where it gets really, really weird. The results for theory of mind are all over the place. Look at the classic Salian test we just talked about. The older model somehow did worse than the younger one. But then on a slightly different version of the task, its score more than doubles. And then on a third version, it's right back down to almost 0. This tells us its understanding is super brittle. It can't take the concept of belief and apply it consistently. So, what on earth do we make of all of this? This spiky, uneven, frankly bizarre performance? Well, that brings us to our final section. And the key here is to see all of this not as a final grade, but as a diagnosis. It's a way to understand what's going on under the hood. You know, the authors themselves put it perfectly. They said the goal here isn't to create some kind of AI leaderboard. The goal is to diagnose which thinking skills are and are not actually learned from this kind of childlike training. It's a tool for understanding the learning process itself.
So let's just pull this all together. What have we learned? Well, first, more data clearly helps an AI get the rules of the physical world. But it really struggles with abstract ideas like what someone else believes or with tricky language. We've also learned that AI reasoning isn't this one single thing. It's this collection of separate, spiky abilities. And this matters. It gives us a much better roadmap for building smarter, more robust AI. And hey, it might even give us a new window into how our own kids' minds grow.
Which leaves us with one final, pretty provocative thought. All these tests, this whole obstacle course, it's just for the AI's toddler years. But if we can figure out how to give an AI a more human-like childhood, what's going to happen when that AI finally grows up?